Welcome to our case study on distributed denial of service attacks. Today we'll explore the nature of DDoS attacks, how they are executed, and the defense measures that can be implemented to mitigate their impact. We'll also discuss a specific case study of a 300 gigabit per second DDoS attack that occurred in 2012. Before we start, please note that not all details of the incident have been publicly disclosed by the affected company. However, sufficient information is available online and within the cybersecurity community to infer the probable events. While we've made every effort to ensure accuracy, we assume no responsibility for any inaccuracies or consequences of using this information. This case study is adapted from a presentation by Matthew Prince at the Black Hat Conference in 2013. The information is based on a 300 gigabits per second DDoS attack that occurred in 2012. You can find more details in the Black Hat presentation video available on YouTube. Today's learning objectives are explaining DDoS attacks, explaining reflective DDoS attacks, understanding IP spoofing and traffic amplification, and describing common defense mechanisms to defeat DDoS attacks. So our case study focuses on a 300 gigabits per second DDoS attack that took place in 2012. The information is sourced from a Black Hat presentation, Lessons from Surviving a 300 gigabits per second denial of service attack by Matthew Prince. The YouTube video provides additional context and details. So a little background. Black Hat is one of the top security and hacking conferences in the world. It's held annually in Las Vegas, Nevada, and the conference attracts professionals from every corner of the world, offering research presentations, training workshops, and networking opportunities. Denial of service attacks, DOS attacks. These type of attacks aim to make a service unusable by overloading a server, router, or network link. These attacks focus on depleting a network's bandwidth, system resources, or application resources, rendering the targeted services inaccessible to legitimate users. Distributed denial of service attacks. DDoS attacks involve multiple systems launching coordinated attacks to generate higher traffic volumes. These systems are often comprised of PCs or workstations referred to as zombies, which form a botnet controlled by the attacker. So, here's our first case study discussion point. Briefly explain what happened in the DDoS attack. So between March 18th and 21st, 2012, Spamhaus increased annoyance DDoS attacks in the 0 to 80 gigabits per second range. However, from March 24th to 25th, the attack peaked at a staggering 300 gigabits per second. This overwhelming traffic volume severely impacted their operations. So let's talk about the victim. Spamhaus is an international nonprofit organization dedicated to tracking spam operations and their sources. Their website, spamhaus.org, was the primary target of the DDoS attack, highlighting the organization's role in combating spam. So, why does 100 gigabits per second usually considered the magic ceiling in most DDoS attacks? Well, this is often due to hardware limitations of many routers, which can struggle to handle traffic volumes that exceed that threshold. So, this is for this slide and this slide. So we're going to talk about just how large 300 gigabits per second is. So, but to put this attack into perspective, let's compare it with Google's average search time, or average search traffic, excuse me. Google processes around 40,000 searches per second, with an average page size of 300 kilobits. This equates to roughly 100 gigabits per second of traffic. The DDoS attack on Spamhaus was 3 times this volume, demonstrating its sheer magnitude. So, how did the attackers amplify the attacking traffic using OpenDNS servers? DNS amplification involves sending a small DNS request to an open resolver, which then sends a much larger response to the victim. This technique significantly amplifies the attack's impact. So here's just sort of a small, easy to remember bite-sized piece of information. DNS amplification is a small DNS request which equals a lengthy DNS response. So there are a lot of open DNS servers, and this is sort of kind of a blessing and a curse. First of all, they can provide data redundancy and load balancing for legitimate DNS queries, and they can also improve performance by caching responses. The cons to this is they're vulnerable to abuse in DNS amplification attacks, and attackers can misuse them to generate large amounts of traffic with relatively small requests. So with an estimated 28 million open DNS servers worldwide, the potential for abuse and amplification attacks is significant. So let's discuss how to create a packet with a spoofed IP address. Methods include using Python scripts, IP table masquerade, C-socket programming, and various packet sending tools. Creating spoofed packets is a common tactic in DDoS attacks to mask the attacker's identity. So, how can you make a packet with a spoofed IP address routable on the internet? This starts with networks that allow IP spoofing. Once a packet is on the core internet, source IP addresses are generally not checked, enabling that spoofed packet to travel to its target. So, IP spoofing. Good networks don't let packets originate from IPs that they don't own. However, many networks don't follow the best practices allowing IP spoofing. This is generally due to misconfigurations and just ignorance about how networks work. More than 20% of networks still allow IP spoofing, and this poses a significant security challenge as attackers can easily exploit all of these weaknesses. So the challenges of IP spoofing include finding networks that allow IP spoofing, hacking into machines within those networks, using botnets or zombies to launch DDoS attacks simultaneously, and crafting carefully and executing the plan to maximize impact. So, a reflective DNS attack with amplification involves using OpenDNS resolvers to send amplified responses to the victim. This method can significantly increase the volume of attack, overwhelming the target's network and resources. So, Anycast is a technology that allows multiple servers to share the same IP address, which makes it difficult for attackers to target a specific server. There are about 3 ways that Anycast defeats DDoS attacks. First being, it's really difficult to target a specific server with multiple servers sharing the same IP address. A second way is through traffic distribution. Anycast distributes traffic across multiple servers, which reduces the load on individual servers, and it also makes it harder to saturate this kind of network. And improved scalability. Anycast allows easy addition or removal of servers, which makes it easier to scale and adapt to changing traffic patterns. So Akamai is a content delivery network, a CDN, that provides a global platform for delivering digital content. To defeat DDoS attacks, Akamai's Edge network is designed to be distributed, which makes it difficult for attackers to overwhelm a single point. Additionally, Akamai's traffic filtering capabilities block malicious traffic at the edge, while Content Scrubbers removes unwanted traffic from the origin servers. Rate limiting prevents overwhelming origin servers, and IP blocking blocks IP addresses of known attackers. The second type of DDoS defense we'll discuss is IP traceback. This approach tries to find the closest router to the attackers. One way to achieve this is through packet marking, also known as path identification. Routers mark some bits on each received IP packet, typically in the 16-bit ID field, to create an indication of the particular path that an IP takes. However, this approach has significant drawback. It can be very complicated, making it difficult to detect attackers who are far away from the targeted network. In other words, faraway attackers cannot be detected using this method. This limitation highlights the need for more sophisticated and robust DDoS defense strategies. The next type of DDoS defense we'll discuss is packet filtering and rate limiting. This approach is designed to prevent malicious traffic from entering or leaving your network. So, egress filtering is the process of blocking outgoing traffic that originates from your network. This is done by checking the source IP address of each packet. If the source address doesn't match to your network, the packet is dropped. Ingress filtering, on the other hand, is the process of blocking incoming traffic that is destined for your network. This is done by checking the destination IP address of each packet. If the destination address is within your network, but the source is not, the packet is dropped. By implementing packet filtering and rate limiting, you can effectively prevent DDoS attacks from overwhelming your network. This is a robust and effective way to protect your network from malicious traffic. To use packet filtering and rate limiting to defeat DDoS attacks, you can follow these steps. 1. Configure your network devices to filter incoming and outgoing traffic based on source and destination IP addresses, ports, and protocols. Step 2. Implement rate limiting to restrict the number of packets that can be sent within a certain time frame. This can prevent a single attacker from overwhelming your network. Step 3. Configure your network devices to log and monitor traffic patterns to detect and respond to DDoS attacks in real time. By implementing packet filtering and rate limiting, you can effectively prevent DDoS attacks from overwhelming your network and ensure high availability and performance for your digital services. So, how can you help? First, it's really important to check, are you running OpenDNS resolvers? As we previously discussed, this can be a target for DDoS attacks. Next, make sure your network does not allow IP spoofing. Very important, and as you could see earlier, many networks still allow it. Help each other. Look out for things on others' networks, and communicate. Forums are a great place to discuss cybersecurity issues and a great place to get troubleshooting advice. Also, keep an eye on IT security news. Let's talk about the peak of DDoS attacks. We saw a surge in DDoS attacks between 2000 and 2009, but nowadays we don't see nearly as many DDoS attacks making headline news. Why is that? Well, one reason could be that DDoS attacks have become more sophisticated and also harder to detect. Attackers have developed new techniques and tools to launch DDoS attacks, making it more effective and more difficult for networks to defend against them. Another reason could be that DDoS attacks are no longer as newsworthy as they used to be. With the rise of social media and online news, the public is more aware of cybersecurity threats and less likely to be shocked by a DDoS attack. And finally, it's that DDoS attacks are still happening, but they're not making the headlines because they're being mitigated more effectively by networks and by cybersecurity professionals. So what do you think? Why don't we see as many DDoS attacks in the headlines anymore? Here is a great stat website to kind of check the data on that. So to summarize, what are the effective ways to launch DDoS attacks and the effective defense mechanisms against them? Launching DDoS attacks often involves botnets, IP spoofing, and amplification techniques. Defenses include caching, IP traceback, packet filtering, and rate limiting. And finally, here are some of the resources and references used for further reading. Thank you for your attention. Keep your eye out for more cases.